This is exam 1, problem 1. So we have a pelican diving into the water at a 20-degree angle, and we need to write some Python code to update its position. So the very first thing we need to do is figure out what its initial velocity is. Our angle is 20 degrees, so the horizontal component of that will be simply whatever the initial velocity was times the sine of 20 degrees. And then so we call that Vx. Then Vy, the vertical component, will be the cosine of 20 degrees. So here's Vx, and Vy will come down here. So now, the problem gives us some initial conditions in the code. So it tells our position, we just set that equal to the origin. And now we need to write that initial velocity. So in Python that looks like we need to write vector, and this is the syntax. The x component was, if you recall, the velocity times sine theta. So that's just 15, which is what tells us the initial velocity is. Sine of 20. Oh, there should be a comma there. And then in our y direction, we're actually going down, so we're going to make this a negative 15 cosine of 20, and then no change in the z direction. We're starting at time t equals 0, set the acceleration due to gravity. B is the force for, it's not a force, it's a proportionality constant for the magnitude of the drag force, and then we're going to have our change in time to equal to 1,000ths of a second. So now we need to add some code to update the position. So the first thing we need to do is find our net force. So scroll down a little bit. So what are the things acting on the pelican? So the first thing is gravity, so I'll just name that Fg. And so that's going to be a vector. Remember, everything has to be in vectors in Python. And nothing in the x direction. Negative g times the pelican's mass in the y direction, 0 in the z direction. And the other thing acting on the pelican will be the water, which causes the drag force. So let's say call that F of water. And that's going to be equal to negative b times the pelican's velocity, and the problem told us that the drag force was proportional to the speed cubed. So the velocity, we're going to times the velocity by its magnitude. So the magnitude of the, and we're going to square that. So now the syntax is getting confusing, so you really gotta pay attention. So then the net force is just equal to the sum of all the forces acting upon it. So F of the g plus F of the water. And now that we have our net force, we can use Newton's second law to determine what our final velocity is. So we're gonna rewrite this and say the pelican dot velocity, and we're gonna be updating this is equal to what it was, the initial velocity, plus our net force divided by the mass, and then times our change in time. So now that we have our new velocity, we can update the position. So the pelican position is going to be equal to what the position was previously, plus our new velocity times our change in time. And that's it.